So as the size of circuit increases, I think charge distribution method also not advisable. Then what is advisable? The advisable thing is we'll go for the nodal analysis. Nodal analysis can also be applied here. It's quite very easy for you with the nodal analysis. For any circuit, you can draw it. Charge distribution only for limited, some sort of thing, that one. So I'm going to begin with a simple problem. We can solve this by charge distribution. Instead, I'm showing this one. So let this be 0 volt. You can pick up anything. So let me. 0 volt, let me define like this here. Then this is 10 plus x. Let this be x. Then this should also be 10 plus x. Then what should be the potential? This should be 20 volt, because the potential difference across a cell. Who is going to help you to define potential? The cell. The drop across a cell should be equal to its potential difference. Keeping that in mind, we define potentials at the various junctions. Then this should also be x. Then afterwards, charge of a cell should be conserved. No? So what we have, these plates. I'm putting yellow color shade. So charge of these 3 plates should be conserved. But there is a cell in between. I think still it should be conserved, no? Okay, writing nodal equation at this particular point will get the required answer. But we don't know charge. That's what we should try to write the nodal equation. A charge of this 3 plates should be conserved. No? What was the initial charge? 0. Or you, if you want, you can go for these plates. Anything. How many unknowns are there? Only x is unknown. Somehow you should bring that equation for x. Problem will be solved. Sir, even charge is not conserved also, you can avoid. You can go for, okay, x is there. No, I should bring x here. I'll do one thing. I will shade yellow different. Let it be this one. Now look at this. Nodal analysis, you're going to apply it. So don't distribute any charge. Leave it. Don't bother, sir, charge here. Q1, Q2, Q3, nothing to do. Just come for at node X. Okay, there's some point will indicate. P at node P. Directly jump into the problem. At node P. Charge of that should be equal to 0, no? If there were any initial charge, bring that initial charge also. That's the only thing. So charge of this should be conserved. So X minus 0 into 4. So how you define charge? Capacitance into potential difference. So first thing is like X minus 0 into 4. Q equal to C potential difference, or say like 4 into potential, capacitance into potential difference, plus this will be capacitance how much? 2 into X minus 20. Plus this should be 10 plus X, potential capacitance is 2, 10 plus X equal to 0. Ten plus X minus 0. Try to all set equal to 0. Why 0? Because initially there is no charge in that system. So I think this will be very useful for you. I'm telling this one. We'll get answer. You see this one. Now this will be 4x plus 2x minus 40 plus 20 plus 2x equals 0. Anybody value of x?
2.5.
2.5 volt. Once you know x, you can easily tell no what is the charge capacitance in each and every capacitor. Like this, how many nodes are there? Those many nodal equations will come. Those many unknowns will be there. So once you know x, now you know x equal 2.5. So you can calculate the charge. You know 10 plus x value, this 0. You know the charge. You know x and you know this 20. You get the potential difference and you'll get the charge here. Now biggest problem for you, so there is a battery is there. You need to bother. The charge of these plates are conserved. So charge of this Q1 plus Q2 plus Q3 equal to 0. What is Q1? Potential difference into capacitance. That we write directly here because what teachers should teach here, teachers should not write anything Q1, Q2, Q3. The moment you, if I say that write Q1, Q2, Q3, again, biggest problem for distribution of charge, no? So no need to indicate even charges also. Please make a practice. Maybe you may find initial difficult, later on you find very convenient. I need not to bother what charges, positive plate, negative plate, is this positive, is it negative? I need not to bother. Just like, what is the charge here? Potential difference into capacitance. So charge of these plates are conserved. So we can also solve by this what, like charge Q1, year Q2, year how much, so like a year charge Q2, so like a Q2 will come Q1, Q1 plus Q2 year. We can solve this. If you want, I'll show it. So definitely you will thank me that, okay, sir, teaching very good method. Thank you very much. Your comment should be like this. 20 volt. This is 10 volt. This is 2 farad. This is 2 farad. This 4 farad. So what is the charge distribution? I'll put like this: Q1 minus Q1. Here. Or if you want to write Q2 minus Q2. Q3 minus Q3. Then charge of a what should be the conservation of charge principle? Charge of a plates. Q minus Q1 plus Q3 plus Q2 should be 0. Or since I took it, let me go for this one. Okay, fine. Q1, Q3, Q2, charge of this. What is Q1? Potential difference into capacitance. What is Q3? Potential difference into capacitance. What is Q2? Potential difference in capacitance. So instead of giving charges, writing this conversion of charge, then finding Q1, Q2, Q3 directly. This is not advisable. Not advisable means don't forget. When you have nodal analysis, this is not needed to think. Why? Means distribution of charge will be very difficult. Distribution of charge in bigger networks